Hi and welcome to this lesson. You're going to learn about what Git is. Now you've seen from this course we're going to be covering things like GitHub and Bitbucket, and as you can tell there's Git and GitHub, they both have the word Git in it. Now what does it actually do? Let's break that down for you. Now you're going to see shortly in GitHub versus Git, but the main thing is that it's local, meaning it runs on our local machine. And the main purpose of Git is to track changes. And the reason this is useful, especially in software development, is that we can create a file, we can then make some changes to it, and we can track it. So let's say throughout the months we keep working on it, and it gets to the point where something breaks. Well, what we can do is we can look back at what we've currently got and go back in commits and see what the original was, or what the previous one was, or the one before that. And what usually refers to as the position of where we're at is something called head. Normally it's at the latest commit, but we can move the head. We can move it backwards, or we can move it forwards. But let's break down what is a commit. We've touched on head, we've talked about how we can track files locally. What are commits and how does it all work? Because tracking changes is good, but why do we actually need it? What is the main purpose of it? And why is it so popular? This lesson is going to be quite intense. We're going to be covering a lot of theory right now, but trust me, as soon as we start getting involved with the practical side of this, it's going to make perfect sense and you're going to be really glad we covered it. Git is not complex. Don't let it intimidate you and don't worry about it, because I'm going to show you a really simple way to understand it and it's going to make perfect sense once you see it. So as we mentioned, we have one file. We've run Git init and we now have a Git repository. And this in effect is the folder we're working from. So in this case, our repository is the folder and we're going to call it code. Now right now we have one file. So let's say we now go ahead and create a second file. Now there's a change. We've now added something, but what we need to do is make Git aware of this. I'm going to go on a bit of a tangent here. I've mentioned that this is local, but very shortly when we start getting involved with the cloud, I think now it would make a little bit more sense to start introducing it because we're working locally. We might be creating new files, we might be adding them, and what we want to do ultimately is put them in a central place to store them, which is where GitHub and Bitbucket come into play as it's now in one central location. So the work we're doing we can put in one central place. Now again, we are going to cover this in a bit more depth very shortly, but as we can see here, we now have two files. But Git currently is aware of this one, but it's not aware of the second one. So what do we need to do? Well, the first command we're going to run is Git Add. Now what it does is it puts the file into something called the staging area. And once inside the staging area, we can add multiple files, we can remove it. The purpose of the staging area is to prepare our commit. So we may want to include only certain files. And again, going back to this example, imagine we had 10 files. But you might, for example, only want to add 1 or 2 files inside that particular commit. And the reason for this may be you're using Jenkins and it's going to go ahead and build something and you don't want it to include all 10 files. There's only 2 particular ones you need to include. So that's the purpose of the staging area. So now what happens is Git makes a note of this. And now it says in the staging area, it now has one new file. And the way we can check this is by running a command, which is Git Status. So now what we want to do is go ahead and actually make the commit. And this is the most popular command there is, which is Git Commit. And what you'll commonly see with it is a flag, which is -m, which is short for message. And usually inside a couple of quotes, you'll see a little message. So it might be something like my commit. And what this now does is it takes this file that Git previously wasn't aware of and now makes it aware of it. And every time we make a commit, there's something called a Git Hash, which represents the latest change. Now, usually you might see a shorthand of it. It's going to be a small SHA sum, so it might look something a bit like this. And as we mentioned before, Git is linear. And I appreciate there's a lot to take on board right now, and this is going to make a lot more sense once we start diving into the demos. But if we think of Git as one long line, every commit gets a unique hash. And what it does is it allows us to look throughout time at the files and changes made to those files. So you might see this commit here. This might be the one we just made. So we'd see a little message like my commit. In this one, the files might get removed. And in this next one, they might get replaced. And we touched on the concept of head. If this is the latest here, then this is where the head is. And head is like a pointer. Let's say the code in this latest commit here is bad and it doesn't work. Or what we can do is we can just simply roll back. And this is one of the popular features with Git, is the fact all these changes are tracked Can you imagine that if we then went ahead and said, okay, which line actually broke it? It worked previously because it's tracked. We've got the previous commit, we know it worked. And then with the latest one, something broke. The fact we can so easily roll back and roll forward shows why Git is so popular. And while we're here talking about Git, we might as well cover one of the more interesting features, which is something called branches. You're going to see this all the time in the graphical interface. So again, we mentioned that Git is very linear. We have our different commits, and we have something called branches. And the best way of thinking of it is a line of commits. And typically the most common branch you'll see is one called master. If you have a project that only you work on, typically you're not going to have other branches. But when you start working in teams and introducing concepts like branching strategies, which we are going to cover later in the course, this is where you'll start really seeing the concept of branches. And what you might do is say at this point here, this is the latest commit. What you would do is effectively create a snapshot of the current branch, in this case master, at this point in time, and a branch now creates a new line. Now you can keep working on the master one, but you can also work on your new one. So typically, if you didn't want to pollute any changes in here, let's say you were making some experimental changes with something, you don't want to break master if that's being used in production. So instead, you would use your own branch. And then you make your commits, you're happy it works, what you'll then do is merge back into master. Now there's two different options here, you've got merge, you've got rebase, and we are going to be covering it. This lesson has been super intense. There's a lot of theory here, and I really do ask, if you have been struggling, bear with me, because when you start seeing this used practically, it will make a lot of sense. Git isn't complex. The important thing to remember with Git is that it's all about tracking changes. And ultimately, when we're working in a team, that's exactly what we want. We want to track every single change in the code. So now we've seen how Git is used locally, let's have a quick look at the difference between Git and GitHub.